All right, so this time we are going to use trigonometry to find some missing sides. And in this example, it says set up a trig ratio. And so this time what we've got here is, let me use this color. We've got angle B, and that's the one that we're given. So in reference to angle B, X is our opposite side because it's the side that's not touching. And we know that 9 is our hypotenuse. So if we think back to SOH, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is opposite over adjacent. We have op and hype. And so if we have op and hype, we want sine. So we're going to say sine of 21 degrees is x over 9. And I'm going to throw a 1 under this. And then I'm going to use my calc. Or you could use the trig table. But if I find sine of 21 degrees, I'm getting that as 0.3584 when I round it over 1 equals x over 9. And then I can do it a couple different ways. I can do cross multiplication if I like that, or I can just think about trying to get x alone. I would multiply both sides by 9. And that would make me have, these would cancel, and I'd end up with x is equal to 9 times 0.3584 is 3.2256. 3.2256. Most of the time when we round to 1 or 2 decimal places. I'm going to think of it in terms of money. So I'm going to call that 3.22. I have to look over here at the 5, and I'm going to call it 3.23 is equal to x. One thing you want to double check, your hypotenuse should always be the longest side, and 3.23 is definitely smaller than that. So that's a good sign. So here is my setting up my trigonometric ratio, and I'm solving for x. So I'm getting everything nice and set up. So please do some quality work. It makes a huge difference in how well you do at this. So again, let's go back. This time we're given an angle, and the angle that we're given here is that 50 degrees. So this is our angle, and everything is in reference to that. The hypotenuse I don't need because it's not marked. This would be the hypotenuse over there, but I don't need it because it's not marked. My opposite side is over here, and my adjacent side is one of the two parts that's touching the angle that I have, but it's not the hypotenuse. So this is my adjacent. And so when we have opposite and adjacent, we have tan. So we want tan of C is opposite over adjacent. So tangent of 50 degrees. The opposite is x. The adjacent is 20. And I'm all set up. So I've got my trig ratio set up. I want to definitely see that, please. And then you're going to fill in the parts that you know. So we go to tan of 50, and I'm getting 1.1918 is equal to x over 20. And I can think of it just like an algebraic problem. Undo dividing by 20 with multiply by 20 on both sides. These will cancel, and I will get x is equal to 1.1918 times 20, 23.836. And again, if we go 2 decimal places, we look over here and we call that 23.84 is equal to x. I don't have the hypotenuse this time, so I can't tell if that's a smaller number than the hypotenuse. And I'm going to just keep going. So I'm going to do one more of these with you. That blinky guy is right there. Let's see if we can move it. Nope, apparently it's just there and blinking. I don't know why. So this time we are trying to find x, and we're given C. So 13 is our hypotenuse, and we are not given the opposite side. We want to find the adjacent side. And so we would have cosine of 37, because we know cosine is adjacent over hypotenuse. That's going to be x over 13. And there is my nice trigonometric ratio. I can put the degree sign in there so I'm not cheap. And then I'm going to look for cosine of 37 degrees. I'm getting on my calculator 0.7986 is equal to x over 13. And I want to get x all alone, so I'm going to multiply both sides by 13. And then I'm going to get 796 times 13. I'm getting 10.3818 is equal to x. If I go two decimal places, I'm over here at 1, so I'm going to leave it at 10.38 is x. Okay, so in number 6, this one's slightly different, but maybe we don't realize it yet. So let's go ahead and take a look at what we got going on. 65 is our angle, and we don't have the hypotenuse, but we do have the opposite side. So 7 is our op, and x is our adjacent. So if we go back to our SOA, if we have opposite and adjacent, we want tangent. So we want tan of 65 degrees is opposite over adjacent, so 7 over x. Now this time the x is in the denominator, which makes it seem a little bit weird. It's not awful, but I'm going to go back to that idea of putting it over 1. Wow, it's really thick. Let's get one that's not so thick. And I'm going to go and figure out my tan again. So I'm going to hit tangent of 65 degrees, which they tell me is 2.1445 over 1 is 7 over x. And I'm going to go ahead and cross multiply that. That's going to give me 2.1445x is equal to 7 times 1 is 7. And to get x alone, I'm going to go ahead and divide both sides by 2.1445, 2.1445, and we're going to get x is equal to 7 divided by 2.1445 is 3.26416. Let's go two decimal places. We look one to the right. 4 is not high enough to round up, so we're going to get x is equal to 3.26. And that one's finished. So not a lot different, but sometimes it looks a little bit weird when the x is in the denominator of the fraction. So let's go ahead and try this next one. I'm going to use here's my red. This is the angle that we've got. And I have the hypotenuse this time, and I have the 14. So that's the adjacent side. So if I scroll just a teeny bit up, that tells us we want cosine because it's adjacent and hypotenuse. So cosine of 34 degrees is the adjacent side, so 14 over x. And again, the x is in the denominator, so I'm going to go ahead and put a 1 underneath that cos of 34. I'm using my calc to get cosine of 34 degrees, and that's going to give me 0.8290 over 1 is equal to 14 over x. Then I'm going to switch my colors here. I'm going to use a little purple, cross multiply. And I bring this right over here. So that's going to give me 0.8290x is equal to 1 times 14 is 14. And then I'm going to go ahead and divide both sides by 0.8290, 0.8290, and we're going to get x is equal to 14 divided by 0.8290 gives us 16.88781. Two decimal places. This 7 is enough to bump me up. So I'm going to get x is equal to 16. Instead of 88, we're going to go 89. That's going to be our final answer on that one. We've got one more problem here. This time we've got our angle of 64 degrees, and the 43 is the opposite side. It's the side that does not touch the angle. And then across from our 90 is our hypotenuse. So we have opposite and hypotenuse, so that is our SO of SOHCAHTOA. So we would like sine of 64 degrees is equal to 43 over x. I'm going to put a 1 under that. And I'm going to find my sine of 64. Now notice each time I'm writing this really nice trig ratio. With or without the 1, it's still a nice trig ratio. Sine of 64 is 0.89879, so I'm going to go 88. I'm going to round a little bit there. Over 1 is equal to 43 over x. Switch my colors over this black color. Cross multiply 0.8988 times x is equal to 1 times 43. That's just 43. And divide both sides by 0.8988. 0.8988. And we're going to get x is equal to 43 when you divide it by 0.8988 gives us 47.8415. 2 decimal places. I look at the 1, not enough to bump me up. So x is 47.84. Final answer. Okay? So whether you end up with an x in the numerator or in the denominator of your fraction, you should be able to deal with the practice problems that are coming up. Okay? Good luck with those.